Welcome to part 2 of our lecture on operations and production management. This morning we'll start or begin with production systems, explanation of production systems. Then we'll proceed with the other part of the lecture. So a production system is the framework within which the production activities of an organization are carried out. So there's a framework if you want to undertake production, and it's the production system that will establish the framework, all right? The procedure, or if you want, the steps that you have to take if you want to embark on any production in the organization. At one end of the system are inputs, and at the other end are outputs, all right? So that's the production system. It should be structured that it begins with getting inputs into the system, and at the end of the system, you should be able to get some refined output or finished products from the production system. So inputs and outputs are linked by certain process or operation or activities imparting values to the inputs. So in between the input and the output, you have a process or operation system that is in place to add value to the input that you've put into the system, so that the output will be a refined and an added value form of the input that started the production system. Okay, so these operations or activities may be called production systems. So elements of production system, as you might have known from the earlier explanation, it will start with inputs. You'll get all of the raw materials that you need, or the inputs that you need, depending upon the type of industry. There is some conversion that takes place, processing takes place. So the second step is conversion process. The third step, you get output. The fourth step of the production system is to have storage facility. All right, after the finished products, they may not be sold directly to those that will need them, and so they have to be stored somewhere before they are actually transported to retailers and wholesalers. All right, so you'll need storage. Then the fifth one is transportation to the other intermediaries, and the sixth one is information. Information, even though it's at the sixth end, is part of the system right from the beginning. All right, you need good information system in place to be able to get the right amount of inputs at the right time in order to begin the production process. All right, when you are transforming or converting the input, you also need good information system to make sure that your machines and equipments and technology are up to date. So the information, even though it's at number 6, is something that will be needed at all levels. All right, if you're transporting the goods or the finished products from your plant to wholesalers and retailers and customers, you will need some good information system to track the movement of these goods or services. Okay. So types of production systems. We have two main types of production systems. We have continuous system. So it refers to the manufacture of large quantities of a single or at most a very few varieties of products with standard of processes and sequences. The mass production is carries continuously for stock in anticipation of demand. Okay, so the organization will carry out the mass production continuously in order to stock in anticipation of demand. So it's a system that you produce some product, the same type of product, or just a few variety of products, right, in mass, in larger quantities. So the process is standardized, so that at the end of the day, you can get the same or similar type of products in larger quantities. And so you need a continuous system in order to be able to undertake that type of production. All right. Then we have intermittent system. So there are those where the facilities must be flexible enough to handle a variety of products and sizes. In instances such as this, no single sequence pattern of operation is appropriate. So the relative location of the operation must be a compromise that is best for all inputs considered together. So this is a variation or totally different from the continuous system where you want to produce standard products. And so you can have a standard process or sequence of operation. With intermittent, every product is unique. And so you cannot standardize your processes or operations. All right. Unique arrangements to be able to satisfy the demands of each customer that comes to buy those types of products. Okay, so that type of system is known as the intermittent system. It's different from the continuous system where you can standardize your operations and produce similar products in large quantities. Characteristics of the flow or continuous system. So volume of output is generally large. So it's good for mass production. All right, you're producing the same thing, but in larger quantities. They look the same or they are similar. So you can use the continuous system. All right. If you take, I think, water, mineral water, or what we will call if you even take the sachet water, most of the time, you'll see that the system is structured from the time where input, that is the raw form of water, is put into the system. All the processing is done, and then at the end of the day, you get the sachet or the bottled water coming out. But they don't come in singles. Normally, the production is done in mass. But because they look the same in shape, in color, and everything, you can use what is known as the flow or the continuous system. Okay, the product design and the operations are standardized. Special purpose automatic machines are used to perform standardized operations. There is a fixed part material handling equipment used to predetermine sequence of operations. All right. So if you have been to, as I said, these water processing companies that sell and manufacture bottled or mineral water, you can get a clear picture of the continuous system in operation. Okay, so the machines are arranged in a particular order so that at the very end, you'll get the finished product. But at each stage, some function or some activity is done in order to improve the quality of the water that started the process in the first place. So there is a fixed part, okay, material handling equipment, because there is a predetermined sequence of operation. You move from stage A, you get to B, from B, you get to C until the finished product comes out finally. Okay, 5, machine capacities are balanced so that materials are fed at one end of the process and finished product is received at the other end. I think this is also quite clear. What are the advantages of the flow system? Work in progress inventory is minimized. All right, so minimum. Why? Because it's a continuous process, as the name suggests. At the end of the day, there is no break anywhere until the final product is released from the system. So there is no room for having a lot of work in progress, right? It's when you begin, if there is no any machine breakdown or whatever, normally you have to end the process with a finished product. And so there's the tendency of having a lot of work in progress is minimized. The quality of output is kept uniform because all the raw materials goes through a standardized procedure or steps in order to be able to get the output. Okay, so they tend to be very, very uniform. If you pick bottles of water, most of the time, if you have the same brand, you will not be able to tell the difference between one and the other. Okay, any delays at any stage is automatically detected because it has to flow continuously. Once there's a problem at one step, it is easily detected because the next step will not be able to work until that problem or delay is rectified. Material handling is reduced. So it relies on automated machines that tend to move the work in progress from one place to the other until the finished product. So material handling is reduced. You don't have a lot of manual or humans involved in the movement of goods with this system. Control over material cost and output is simplified. All right. So it's a structured system. The machines take over. You just need minimum supervision and everything gets out of the system. It fosters specialization. People can just simply concentrate in their particular area. All right. So that is it. It offers economies of scale because it's a system that is good for mass production. And we know the advantages that come with producing mass. You buy the raw materials in volumes that can give you discounts. What again, you are able to utilize your machines in full capacity, and therefore that can help to be able to redeem the cost, the fixed cost associated with that particular machine because it's operating at full capacity, and so on and so forth. Okay, if you can get discounts, as I said, and all other benefits associated with mass production, known as the economies of scale. What are the demerits or the disadvantages of the flow system? A breakdown in a machine will lead to shutting down a production line. All right, so it's a continuous process. So once there is a breakdown at any of the stages, any of the machines, what it means is that the entire line cannot continue. Okay, yes, if there's a problem, the work in progress cannot move to the next stage. And so the entire production system must come to a halt. Investments in machines are relatively high. As I indicated earlier, it relies a lot on automations or automated machines. And so you need to invest a lot and investing in such machines. So types of continuous system, we have mass production. All right. So it's the manufacturing of standardized parts or components on large scale. Mass production system offers economies of scale as the volume of output is large. Under the same continuous system, we can have process production. It's where production is carried on continuously through a uniform and standardized sequence of operations of highly sophisticated and automatic machines. Okay, example, fertilizer plant, petrochemical plants, and so on and so forth. So we have the process where we just explained, just as the name, continuous system. It must continue in a uniform and a standardized sequence until we finally get the output out of the system. Characteristics of intermittent system. The flow of production is intermittent, as the name goes, and not continuous. All right, so there is a break. The last time I was talking about how if you go to, say, furniture manufacturing company may go through the steps, right? It may be cutting, it may be joining, it may then be polishing or finishing. Each of these stages can be independent of each other. All right, okay. The process doesn't have to be continuous. So that's the idea here with the intermittent system. The volume of production is generally small. If we compare it with the continuous or the flow, intermittent systems, the volumes are normally very, very small. A wide variety of products are produced. So with furniture, if it is not a company that is actually producing mass to sell to the general public, if it's a company that must rely on the orders of their customers, then each furniture is likely to be very, very different based on the specifications of the clients or the customers that will come asking for that type of furniture. Okay, process layout is most suited, all right, for the intermittent system. No single sequence of operation is used, and periodical adjustments are made to suit different jobs. I hope this is clear because each request, each product is quite different from others. And so you need to adjust your operations to meet the specific demands or requests of customers. General purpose machines are used because you have to keep changing and adjusting these machines based on the demands and requests of your customers and clients. So types of intermittent production, we can have job production. It involves the manufacturing of single complete unit with the use of a group of operator and process as per customers' orders. Okay, so job production is where you operate to meet the demands of a particular customer order. All right. So it's just a single thing. Somebody comes and says he wants a table of a particular type. And so you go to work adjusting your operations and cutting your woods and everything to fit the requirements or the orders of the customer. That is job production. Then we can have under intermittent batch production. So it's the manufacturing of product in small or large batches or lots at intervals by a series of operations, each operation being carried out on the whole batch before any subsequent operation is performed. All right. So the same, as I explained much earlier, with the same furniture company, okay, they may choose, if it is a company that decides the quantities that they want to manufacture before actually selling to the general public. And then that is different from job where it is a company that takes specific orders and specifications from their clients. With batch, the company may choose to produce some quantities and sell those products to the general market. If that is the case, they can choose to work in batches. Okay, they can choose that today we just want to do cutting for 100 type of furniture or tables that we want to manufacture at the end of the day. The next day, they can decide to devote the day to joining of these parts of woods that have been cut. The next day can be devoted to the finishing and the polishing. All right. So that is the batch production. Or one day want to do 100, but first week we want to do 10. Next week we want to do 10 until finally we are done with the whole of the 100. Okay. So it's possible with intermittent production to do what is known as batch production. You can either take the parts or you can choose that I'll be doing the whole product, but I'll sequence it in a way that I'll be able to produce them in batches. So 10, 10, 10 for 10 weeks will be able to give me 100 tables or chairs if you are into furniture manufacturing. Okay, characteristics of job production. The product manufactured is custom made or non-standardized. Custom made means that it is based on the request and the specifications of the customer. All right, it is not mass production, it's not standardized. You actually wait for the specification of the customer, then you produce to fit those specifications. Volume of output is generally small. All right, because it's based on the demands of customers, you will not have one customer actually demanding a lot. And so the volumes are normally very, very small. Each time it's just one type of product for a particular client or customer that you may be producing. Variable part materials handling equipment are used. Why? Because the outputs are not standardized. And so you may have to use different parts to be able to get the output for the client or the customer. A wide range of general purpose machines are used, okay, because the products are not standardized. It is flexible. You can always adjust your machines and your equipment based on the job that is at hand. A breakdown in one machine does not result into complete stoppage of the process. Unlike the continuous system, this time around, assuming you were into the manufacturing of some furniture, say table, and you wanted to manufacture 10, you have done a cutting for about 5. And the machines that are used for a cutting actually breaks down and you can no longer continue with the cutting. But you've been able to get wood for say 5 tables out of the 10. You can proceed to the next stage and do the joining for the 5 tables and then proceed to the next stage to do the polishing for the 5 that you were able to do. Okay, that is not the case with flow production. With flow, once there is a seizure, the system ends there. You cannot proceed with your operations. All right. Yes, so that is the whole idea. Waiting period between operations is reduced because one step finishes, you can then move to the other step to continue. It is time and cost effective. It also reduces material handling. Okay. It reduces, but if you compare the time factor and material handling, in relative to the flow, as we explained, this may be a disadvantage if you compare it to the flow system, but all the same, it is still an advantage because it still follows a particular sequence. After one step, you move to the other, and so it reduces material handling, and you may have arranged your operations to follow the sequence, right? From cutting, the goods are moved to draining. If you have a good system in place, the distance between the cutting of the parts of the wood and the draining should not be so far, so that you don't have to spend a lot of time and cost and wastages and damages as a result of material handling. Okay. The merits or disadvantages of job systems: work in progress is often high, so it is not continuous, so you are likely to have a lot of work in progress that must be worked on. It involves complex production system because the system is not standardized. You always have to be adjusting. So you need general purpose machines and equipments that can adjust to fit to the requirements and specifications of clients or customers. Workloads are often unbalanced, all right? So you are not likely to have a flow where, for example, if it is the flow system or continuous system, the machines themselves have capacities that they can take, okay? So if we want to do mass production, the capacity of our machines is 1,000. We can feed the system with 1,000 anytime that we want to produce those types of products. But that is not the case with job system. One time you may have to work on 5, another time you may have to work on 2, another time 10. So workloads are normally unbalanced under job systems. Okay, speed of work is low. Unit of production is often high because you're working on just one job at any point in time. So the unit cost will be high. You are not doing mass where you can spread the cost over the several outputs that may come out of the system. Okay. Characteristics of batch production. So batch is also, you produce in larger quantities, but it's not like the flow. Okay, they are in batches. All right, they're in batches, and it's not like mass production. So general purpose machines are used. It is suited for process type of layout. Large amount of work in progress will be there. Then they could be flexible in production schedules. It's not like the flow, so there's flexibility. Each worker completes one task and then pass down the output to the next worker. Volume of product manufactured is relatively high. If we compare it to the job, it is high. But if you were to compare batch with the flow, okay, or mass production, batch is still less. But if you compare with job production, it is relatively high. Okay. Advantages of batch production: it can make and offer variety of products. All right. It reduces boredom due to employees working on more than one product. So with job, it is one product at a time, but with batch, we have a couple of products that you have to work on at any point in time. It is flexible and can adapt easily to change in product design. So it's flexible, unlike continuous production or flow production. This is quite flexible. A fault in one operation does not result in complete stoppages of the process, and waiting period is reduced. I think I've explained this points much earlier. The merits: work in progress inventory is high because the flow, it is not a flow, it is not continuous. So there are likely to be breaks here and there, and those breaks can create more work in progress. There is no standard production sequence that is followed due to frequent changes in design. There could be high storage costs because of high work in progress, and also time could be wasted if you compare that to flow production. Okay. We come to production planning and control. So what is it? Production planning and control is the planning process that comprises the performance of some critical function on either side. Whether it's planning or as well as the controlling aspect, there are some critical activities that must be undertaken. Okay, so it's planning But the planning and the control is with regards to production. If you are going to produce anything, you need to plan, and you also need to have some control systems in place. Okay, so production planning is the technique of foreseeing every step in a long series of separate operations, each step to be taken at the right time and in the right place, and each operation to be performed in maximum efficiency. So you don't want to waste your time, you don't want to waste your resources. And so you have to undertake some planning before you start your production. And that is what is known as production planning. All right. So we have this chart here to help us. So production planning and control. Under the planning aspects, you have to plan. Yes, that is the beginning point. Routing or routing, you have to establish that. You have to establish your schedules. Scheduling is one thing. We have loading. All right. So those aspects are the planning parts. Then under control, you want to be mindful of dispatching. That is how control begins. Then follow-ups, there should be inspections, and there should be corrective actions taken where there are deviations. Okay, so let's look at this point. So planning is the general thing. Everything is inclusive of the planning. All right, so we're beginning with routing or routing. All right, I think the MIS people normally call it routing. Okay, so it's the establishment of path and sequence for production operations. You need to establish the path and sequence. So you don't start production or working before thinking about the sequence or the path that your work in progress will follow. Okay, the routing part is to establish the path and the sequence that production operations will follow so that there will be a smooth flow until you finally get your finished product. So you need to establish path and sequence. To perform these operations, the proper class of machines and personnel required are also worked out. So each step, you've laid out the sequence or the steps, and you've also determined the machines and the personnel that will be needed at each stage or for each of the steps or path that you've created. Okay, the main aim of routing is to determine the best and cheapest sequence of operations and to ensure this sequence is strictly followed. All right, so that we won't waste so much time using steps or procedures that really will be more expensive and time costly compared to another part. So you need to clearly show the path or the route for the production. All right. Then we move to scheduling or scheduling. It means working out of time that should be required to perform each operation and also the time necessary to perform the entire series as routed, making allowances for all factors concerned. All right. So you don't just begin production straight away without thinking through the timing, the timelines. So you need to establish the timelines for each of the routes or each of the steps that you want to take. All right. So at point A or today, this is what I'll be doing. Tomorrow, this is what we should be doing. The next day, this is what we should be doing. If there's in weeks, this we will concentrate on this. Next week, we have to do this. By week 10, we should be sending these products to our wholesalers or retailers. So there should be timelines to indicate the activities when each activity or operations need to take place. It mainly concerns with time, element, and priorities of a job. So we need that. Then loading. What is loading? Loading is the execution of the schedule plan as per the route chalked out. So establish the routes. If you want the stages that we will undertake to produce the product, we've indicated the timelines. Loading is to begin the actual work, right? So it includes the assignment of the work to the operators at the machine. So when the actual work begins, because we now know the route and we now know our schedules, that step is known as loading. So loading determines who will do the work, as routing determines where, and scheduling determines when the work shall be done. All right. So if you get to the loading stage, it is where the actual work needs to be done. So we have to know who will begin the work. The routing should tell you where the work should be done, right? The steps, the pathways that must be followed. Scheduling is when what should be done. Okay. What then is dispatching? It involves the issue of production orders for starting the operations. It translates production plans into production. So loading is where we now assign people to get the work going. Dispatching is when they actually begin the production. So they are closely related. All right. Loading is to know who is to do what. Then when they begin the process of translating the production plans into production, that is known as dispatching. They have begun. Dispatching means they have started the entire process, right? Then you need to do follow-up. So production program should involve the determination of the progress of work, removing bottlenecks or deviation in the flow of work, ensuring that productive operations are taking place in accordance with plans, revealing defects in routing and scheduling, misunderstanding of orders and instructions, underloading or overloading of work. All of this, you need to do follow-up to check these things. The work in progress, what's going on? Are there bottlenecks in the way work is being carried out? Okay. Is the production working according to the plans that have been put in place? Are there any defects either in the routes that we establish? Are there any problems with the schedules that we put in place? And so on and so forth. All right. So deviations are investigated and remedial measures are undertaken to ensure the completion of the work by the planned date. Then part of follow-up is to do inspections and corrective measures, right? So the follow-up is to make sure you don't have any deviations at all. But when you finally get your finished product, you still have to inspect, because in spite of all the follow-up, there may be some problems with the finished product at the end of the day. So you need to undertake inspection, and if there are deviations, you take corrective action. So inspection is to ensure the quality of the goods. Corrective action may involve adjusting the route, the rescheduling of work, changing workload, repairing and maintenance of machinery, and exercising proper control over inventories. So all of these things could be done. Maybe the problem came from the routes that were established. Maybe upon inspection, the error is coming from poor scheduling. So you need to reschedule. Or it was due to poor workload. You need to think about that. It may be coming due to breakages or damages in machines and so on and so forth. You need to repair that and so on and so forth. Okay. Sometimes the cause of deviation might be due to the poor performance of employees. If that is the case, then decisions like training, transfer, demotion may have to be taken to correct poor performance. So sometimes the issue might not be due to routing, scheduling, loading, machines, or proper control of inventories. It might be as a result of employees not doing well. If that is the case, then maybe they need training. Maybe you have to transfer them. Maybe you have to demote them. Maybe you have to fire them, all right, and get more competent and hardworking employees. So the importance of production planning and control from all the discussions that we've had so far is that it could lead to optimum utilization of capacity, because you've planned the process, all right? So you know the quantities you'll be producing and so on and so forth. There could be optimum utilization of capacity. It helps in inventory control because you've planned everything. You know the quantities you need, at what time you need them, okay? So you may, with proper routing and scheduling, you should be able to even go with just-in-time method of production, where you don't have to keep a lot of raw materials, but raw materials come in just at the point where production is about to begin. Okay. It ensures economy of production time, because we know what should be done, and it will lead to improvement in quality. All right. We have quality control in production and operations management. Quality is an important factor that must be considered. Okay, so quality control involves measuring product and services against established quality standards. So what then is quality is based on the quality standards that were established. It's very, very important for us to make that particular point. Quality is not our perception of what quality is. It's based on the standards that were set from the beginning of our production activity. Okay, so quality control is basically to make sure that our product and services will match the quality standards that we established at the beginning of our production. Okay, so we have the dimensions of the quality. What are the various factors that you have to consider when you're establishing the quality standard? So it could be in terms of the functions, it could be in terms of reliability and durability, it could be in terms of the aesthetics characteristics of the product or service that you want to offer, it could be in terms of safety. Okay, so when you establish your standard with regards to function, these are the things you are concerned with: performing the product, being capable of performing its purpose when put to use. So whatever product it is, I think it's just a requirement by law that a product should be capable of functioning, serving its purpose. All right. So you can sell a mobile phone to somebody in a very nice package, well-looking phone, but that phone cannot be used to make calls or receive calls. If you do that, then the commercial use of that product has not been achieved. And if that is the case, then that is a poor quality product. So with regards to function, the concern of the manufacturing or the production department should be able to come up with a product that can perform its purpose. Okay. The other dimension of quality is reliability and durability. This refers to the length of time. So you should be able to set some target with regards to how long the product should last if the customer was to use it according to the specifications of the manufacturer. And that is also very, very important. Okay, so no matter how good a mobile phone is and how durable it should have been, if you mishandle it and throw it on the ground and so on and so forth, it may not be able to last that long. All right. But if a customer was to handle the mobile phone well, there should be some reasonable period that the mobile phone should be able to perform its functions or stay more relevant to the buyer of that mobile phone. Okay, so that is the idea of reliability and durability. Then you could also have a dimension of quality addressing the aesthetics characteristics of the product. All right, so the product, the physical appearance of the product is important. How do you want the product to look? Very, very important. Okay, is it the product that sells just by its function, or customers and clients will look at the beauty of the product before considering to buy? So depending upon the industry in which you find yourself, the nature of that product, the beauty of the product, its physical appearance could be an important determinant of the quality of that particular product. Then finally, the safety. This concerns whether the product will perform its functions without endangering the user. So function point one is basically whether it will be able to perform its purpose or function. Safety is whether in the course of performing the function of that particular product, it will not harm the user of that particular product. All right. So it is very, very important that to know that these are the dimensions of quality. So quality is not just only durability. All right. Most of the time when we mention quality, that is what comes to mind. Is it durable? No, it could be durable, but not functional, right? It could, especially mobile phones, you can still have it. It looks like a mobile phone. It's probably very nice, but cannot perform the functions of a mobile phone. That is not quality. Okay, so quality must address these 5 points that we have here: functions, reliability, durability, aesthetic characteristics, and safety. important dimensions of quality. Then we have materials management. So it includes all activities related to the purchase, storage, maintenance, and physical handling of goods used by the business. And it's an important aspect of manufacturing in the manufacturing industry. You need to pay attention to material handling. That is where a lot of wastage could happen, a lot of damages and breakages could happen. So if you're into goods, manufacturing of goods, materials handling must be taken, materials management must be an important concern for your business. Okay, so what are the types of goods that you want to be mindful of materials management? Right from the raw material stage, you need to handle them well. You need to move them well. You need to make sure you bought the right quality of raw material, because that will influence your finished product. They should have been stored well. Sometimes you will have bought the right quality of raw materials, but the quality could have deteriorated because of poor storage. Okay, so it is important to have the right systems in place to be able to store this raw materials well. You should have bought them at the right price, because that will also influence your cost of production and ultimately how much you can sell and make profit. Okay, so yes, but material management must be dealing with goods such as raw materials, semi-finished goods or work in progress, finished goods, as well as capital goods. All of these are subjects of goods materials management. So the scope of material management activities are purchase. We just explained that. Make sure that you make the right bargains and negotiations with regards to that. So purchase, we have storage, we have material handling itself, we have inventory control, and we have material planning. Okay. So purchasing, it is a procuring of raw materials, components, and services that the organization needs to achieve its goals. So it's basically that. All right. You have to buy all the components, the raw materials, the services that you need in order to manufacture whatever you want to manufacture. Okay, so the purchasing procedure most of the time will follow this pattern. There is a purchase requisition, like a request. Okay, there is a review of this requisition by maybe another department that is supposed to do the procurement department or something of that sort. That will review the requisition. There is request selection of suppliers. There is then the placing of order. Okay, there is the monitoring of order. There is receiving and inspecting the order. All right, once you select and you place the order, they'll bring the order to you. You have to receive the order. And order simply means the raw materials or the goods that you bought, the components that you requested for. Okay. Inventory control. Inventory control are often referred to as stock. The reasons why firms hold inventory control. So you have to, as part of materials management, you have to pay attention to inventory control, right? Because as I said much earlier, that is where a lot of waste, a lot of losses could happen. Okay, if you buy more and you don't need them, there could be trouble. If you have less than what you need, there could be trouble. So that is it. You need a system and in place to ensure that you always have the right quantities and amount of inventory at your plant. Okay. So the reasons why firms hold inventory include to take advantage of quantity discount. So sometimes firms will buy a lot of the raw materials or goods because probably the more they buy, the larger the quantity discounts they may get. 2, they may hold inventory to provide a safeguard against uncertain deliveries and lead times, right? So yes, you may not, anything can happen. And to safeguard uncertain deliveries and lead times, you want to have some backup. So no matter what happens, you have some inputs or raw materials to deal with such uncertainties. Okay. To meet customers' unanticipated demand. So point 3 is similar to point 2. right? There could be hike in demand at any point in time. You are not sure. And so for some companies, they will want to have some spare raw materials in their stores in case there is a sudden increase in demand from their clients or customers. To hedge against price increases, this could be another reason, right? If you're operating in an economy where the inflation rate is continually going up, maybe the reasonable thing is to buy a lot of those raw materials today and keep them somewhere in order to save yourself from price increases. Material handling, it involves moving raw materials from the loading dock through inspection, production, and storage to the distribution system. So that's the whole idea of material handling, where you have to move goods from one point to the other. And as I indicated, it is very, very important, especially when you are into the manufacturing of goods. You need to pay attention to material handling. All right, so I hope you were able to follow, and this brings us to the end of our lecture on operations and production management. Thank you very much for your attention.